little bit of a lag issue, I think. Um, morning. I think we're good now. It was lagging a little bit earlier, but I think I reset my Wi-Fi and it's good now. All right. So, today we're gonna do it in two parts. We're gonna do 10.8 first. It's gonna take about half an hour, and afterwards we're gonna move to Zoom to play a quick round of Kahoot and say goodbye, and then we will call it a year. Does that make sense? Alright, so we're gonna do 11.8 in about within half an hour, and then we will move to Kahoot to do some quick review. And that's pretty much it. Okay, I'll send you the code to Kahoot and Zoom later. Okay, shouldn't take too long. Okay, here we go. All right, so let's start. Yeah. So, last class. Here we go. So today we're gonna explore spheres. Okay. Explore surface area and volume of spheres. Okay, spheres. Today is the third. Right, third. Okay. So, here we go. So, this is a sphere, like a ball, you know. And this is the point where the locus of the points. Locus is the entirety of the points. Is in space that are a fixed distance from a point called center of the sphere. And then you have a radius, and you go all the way around, right? So these are called hemispheres. You know, you see northern hemisphere and southern hemisphere, that kind of thing. When you have, it's essentially a 3D circle, okay? Because you're in a spherical world, the line on the sphere is known as great circles, okay? We talked about in spherical geometry how the great circle is the longest line around. Same thing as when you're on Earth, right? Your line is actually circles. All right, so today's focus is going to be on volume and surface area. So let's look at volume. So they say volume of a sphere with a radius r is v equals 4/3 pi r cubed. Let's try to visualize this a little bit. The actual proof you can find in any YouTube video, pretty much, but because they have animation, I'll send you the link later on the actual like animated proof for this. But basically, let me explain it real quick. So basically, this is a half sphere, right? Notice we're interested in the whole sphere, right? We're interested in the whole sphere, but I'm only looking at a half sphere, and then I'm gonna multiply by 2. Okay, so half sphere looks like this. So what I'm going to do is I'm going to open this up from the top, and then I'm going to project this part that way. Okay, I'm gonna basically open this part, and then it will turn into this, a cylinder. Okay. However, because I opened this up, I now have a hollow piece of cone in here. Okay, so essentially what my whole volume was like this is now just this. Can you visualize it? Okay, and once you get that, you can find the volume using the cylinder formula and the cone formula, right? So I'm going to use cylinder minus the cone, okay, like that. Cylinder is going to be pi r square h, right? However, when you pull this out, magically, this height actually will then become radius. Okay? So essentially this is pi r squared times r. Okay, same thing here. This will be minus 1/3 pi r squared times r. So that is going to be pi r cubed minus 1/3 pi r cubed, which is going to be 2/3 pi r cubed, because 1/3 subtracted from 1, right? So 2/3 pi r cubed. Well, there are two of them, right? Because you have top and you have bottom. Same thing, you have top and you have bottom. So you multiply by 2, and you'll get this. Okay. This is an animated proof. You can also call this the projection proof. But we are looking at yeah, that's how they got 4/3. Well, one of the ways to get 4/3 pi r cubed. Okay. So we're gonna use it. So look at bottom here. Find the volume of a sphere. Give your answer in terms of pi. So pretty simple. You have 24 as diameter, so radius is 12, right? 12 inches. So volume equals 4/3 pi r cubed. So 4/3 pi 12 cubed. So it's going to be, what's this? 12 cubed. 4/3 times 12 to the cube. 2304 pi inches cubed. Okay. You can try on the right side real quick. Tell me the answer when you're done. You can also leave the answer in pi. Let me know the answer when you're done. So, normal sphere is going to be 4/3 pi r cubed, right? However, here we're only doing half, so we gotta times by half, right? 2250 is pi is correct, I think. So you get 4/3 pi 15 cubed times 1/2. So it turns out to be 2250 pi, inches cubed. Good? Example 2. Find the radius of a sphere where the volume is 2304 pi feet cubed. Well, this is kind of a gimme because we already did that. But let's go to see how you solve. So normally what you do is, you know this is a sphere, right? You know this is going to equal to 2304 pi, right? So you gotta solve for r. Okay, so to solve for r, you're gonna do the opposite. Okay, 230. Well, first of all, you can cancel out the pi. You don't need the pi, right? Cancel out pi both sides, and then you multiply by 3/4. Okay, 304 times 3/4. Multiply by reciprocal. So r cubed equals 1728. So r is then the cube root of this. Cube root. So you get 12. And then this is in feet cubed, so it's just feet. Okay. You try one. So type the answer in when you're done. So somebody got Thomas got 3.7. Anyone else got an answer yet? The ratio between the two volume. Yeah, you're right. All right, so obviously what you could do, the simplest way to do this is actually just calculate the volume for both of them. So you have to find the radius first, right? So you got volume 1 is 4/3 pi r11 cubed, and the other one, volume 2, is going to be 4/3 pi 17 cubed, right? These two are the two balls, and then you calculate them and you take the ratio, right? So that's the way you do it. However, another way to look at it is the following. So you know the radius or the diameter length is 22 to 34, right? Or 11 to 17. The ratio between the volume, because volume is three-dimensional, right? Three-dimensional means that your R will be cubed. So the ratio, the rest is the same, right? These are the same. So the only difference is the cubing. So you can just cube them. Okay? So that's it. So the ratio is going to be 17 cubed over 11 cubed. Like that. Okay? Because the volume is triple, right? I mean, not triple. So let me so I think you're right though. Over 11 cubed. Yeah, 3.69 is correct. Okay. About 3.69. It's a irrational number. Keep going. Oh no, it's a rational number, sorry. It's a rational number. But it's a long fraction. Okay. Alright, flip it over. And are we okay with this? Can I get a 1 to 10 real quick? I got a 10, got a 6, 8, 9. Okay. So, John, one thing that you and Hinata, basically, when you're looking at volume formulas, 4/3 power cube, you just need to remember the formula. But when it comes to ratio, just remember if everything is projected twice in length, then your area will be projected twice, so it'll be squared. And if you're doing volume, it will be cubed. When in doubt, you can always obviously calculate it out, but sometimes they won't give you the actual number. They will tell you, oh, radius is 5 times as large. Then how many times is the volume? So it will be 1 to 5, so it'll be 1 to 5 cubed. 1 cubed to 5 cubed. Okay? Alright. So next part is surface area. Says surface area of a sphere with the radius r is 4 pi r cubed. 4 pi r squared. It's two-dimensional, right? So it shouldn't be cube and stuff. It's squared. So how did they come up with the conclusion? Once again, there is a video about this as well. But basically what they did was the following. Okay? What they did is they break the surface into the small area like this, and then what they did is they found the base area of this small pyramid, and then they add all of it around. Okay, add them all the way around, and they conclude that it's 4 pi r squared. It's a little hard to believe, but when I send you the video, it will make more sense, okay? But let's use it first, okay? 4 pi r squared. So find the surface area of this on 4 pi r squared, and the surface area would be, they tell you the area of 49 pi for this circle. So what's radius then? What is radius? What's the radius? If this is 49 pi, then the radius has to be 7, right? Because pi r squared, right? When you do the circle. Since that's the case, then surface area is 4 pi r squared. Wait, 25? What's 25? What? Huh? Wait. Thought we were doing this one. Oh, anyway. But if you're doing that one would be 25. So 4 times 49, 196 pi. But this one is in miles square. This is the surface area. Okay. Right side. Find the surface area of a sphere. Let's just do this one together because this is a short process. They say this is 50 centimeters, so this radius will be 25 half, right? By the way, if you don't know what this was about, this one is because area of a circle is pi r squared, right? So r squared needed to be 49, so r needs to be 7. Okay? And this part is because it's half, right? So you just do half. This is the diameter. So then you would just do SA equals 4 pi times 25 squared, okay? 4 pi r squared, okay? 25 squared times 4, 2500 centimeters squared with the pi. Okay? Last one. Are we good with this? Just applying the formula, there's not much to ponder upon. All right, last one, challenge. Try this one. So you want to find the surface area and volume of this, okay? Of this. The top is a sphere. So try these, and then let me know if you got an answer. for both surface area and volume, okay? You got an answer yet? Hello? So 216 pi or 264 pi? Okay, here we go. So the volume problem versus surface area problem is different. Volume problem is just basically add the two volume together. So it will be 4/3 pi r cubed, but not just that, you have to divide by 2, right? Because there's only half. Plus the sphere, which is pi r square h, right? Pi r square h, that's the cylinder. So plugging it in, 4/3 pi r is 6 cubed divided by 2 plus pi 6 squared times 9, right? So together, volume is 4/3, 6 cubed. So this is 144 pi plus 324 pi. So together the volume is 468 pi inches cubed. Right, that's the volume. Now, surface area is more interesting because surface area, you're only looking at the ones that are exposed, right? So like the dome on top. So that's half of the normal surface area. 4 pi r cubed divided by 2. Wait. We're doing surface area, right? So surface area is not that. Surface area is 4 pi r squared, but you're doing only half of it, okay? Plus the base, which is pi r squared. Let me just put the formula down first, then we can look at the rest. So 4 pi r squared. Oh wait, pi r squared. Why not? Pi r squared. Okay, and then the lateral area part. Remember how to do that? That part was 2 pi r h. Because this is the lateral part, which is the circumference times height. Circumference pi r, 2 pi r, right, times h. Alright, so plug in the numbers. So this is 2 pi r squared is 6 squared plus pi 6 squared plus 2 pi 6 times height is 9. Okay? So you add them up. This is 72 pi plus 36 pi plus 54 times 2, 108 pi. So it turns out to be got 216 pi inches square. Okay. That's all. Okay. 216 pi. All right. So I have sent the Kahoot link in and Zoom link into your loop mail. So go check your loop mail and join me one last time before the year ends. And I'll also take attendance right now before you go. So type here if you're here. And once you've done that, go check your loop mail. Okay. hello. I'm still in the process of letting people in. You're all muted, by the way. Alright, I'm gonna close off the YouTube, okay?